create an animator for a door or elevator. I'm not talking about doors as in a door that you link cells based on doors that you spawn, right? That's not this. I have a tutorial for that on the website in the link below, so if you want, you can look that tutorial up. But this is for animators. This is the more technical descriptor would be binary state animator, because that's what it is. And we'll touch up on some caveats about that. But first off, what we need to do is extract our resources. If you go to Dragonborn's BSA, and let's go to, let's see here, DLCO2, dungeons, that's not right, attach object, and let's export rotate helper 90CW01. Let's go ahead and do that. And once you have exported that, copy that over to somewhere where you're going to import it. Right, and let's go ahead and import that also. So just make a new activator. And let's call it whatever you want. And let's import that thing that we just exported. Okay, now I assume you already have your door slash platform you want to animate. This isn't going to be a, how should I say this, a multi-state animation. It's not going to be anything elaborate where you have different positions that it moves around. It's just open and close, up and down, just basic rotation. There's a reason for that. We'll get to that later. Advanced animation is tricky to do. So let's have the thing you just spawned. If you get that error, then go to edit, base edit, edit again, change the name, okay, and import it again. So let's just add a platform of some sort. This should work. And let's just put this thing right about in the middle, just for the sake of organization. Next thing we're going to do is add a trigger. Default activate self. This is just to test it. Right, so we're going to just move this here in your cell. Second thing we're going to do is create another trigger, a custom trigger. You will have to create your own. So you will have to add a new script, a custom script. Right, so add new script, object reference, extends object reference, and within this let's add an activation event. And let's put a boolean up here too. And we're going to say that if it is set to true, that we're going to return. We're going to enable it afterwards, disable it, set it to true, and then false after we perform our functionality. So this is, ignore this stuff here. This is not relevant. So here we're going to get the linked reference, and we're going to play animation forward. Then we're going to wait, let's say 3 seconds, and do the same thing. Then wait another 3 seconds. Set to backwards. So you might notice two things here. We're not using play Gamebryo animation here. We're just using play animation. That's the Havoc version. The reason is because there's a Havoc tag in there, Havoc flags that allow for this animation group to be applicable to this particular thing that we just imported. If we use play Gamebryo animation, this is the legacy version, that's viable, but there are a few caveats, and I should say it's only partially viable. Right, so here's an example. This is the legacy style animation. So you notice that it's incrementing only a tiny bit for each keyframe. The thing you can do with the Havoc animation is that you can ignore that. It's basically, I mean, you can make all kinds of excuses for Bethesda, but it's Bethesda just doesn't give a shit about software engineering and you know the quality of their game engine. Like there's ultimately there's no excuse for this, but that's just the way it is. So anyway, what we're going to do now, once we have this, let's save that script. Okay, and we have to set a few things up first. Let's open the default activate self, disable do once, so set it to false. Okay, second thing we need to do is this shouldn't really be bounding box, but it doesn't really matter for this. So here you're going to go to activate parent, select the default activate self trigger, and also in the same trigger you made, we're going to link reference to that thing we just imported. Now, it's good practice to do a basic setup test, unit test, prior to mangling the NIF file, so that's what we're going to do. Last thing we need to do is click on the thing you want to animate, the actual static mesh, and then within attach ref, select that little animator we just imported. And we're going to save this. So once you have tested that and that works and everything, you're going to open the thing you just imported, the animator. So I have that here. Now remember, we're not doing direct animation, we're doing attach reference animation. If you want to do direct animation, as a couple more caveats, I'll do that some other time. It's mostly the same thing, but again, there are some important details to note. So here we have this thing. So the NI-controller sequence is the animation itself. That's the actual animation you see, and different NI controller sequences represent different animations. All of this is controlled by an NI controller manager, and the thing that basically directs what occurs within these NI controller sequences is the NI multi-target transform controller. This particular kind of controller allows you to manipulate multiple NI nodes that you can put in here. But we're not messing with all that. We're just messing with the NI transform data of the play 01 and play 02. Potentially, let's see if this has any. I don't recall that you would need idle 02 to be changed based on play 02, so we're just going to ignore that for now and come back to it. So what you want to do is, well, we don't really need rotation keys, right? We're going to set that to 0. We're going to put 2 translation keys. This, I'm assuming we're making an elevator. If you want a door, keep the rotation keys and just adjust the rotation. Or maybe that was it in the first place, what you had. If you do want a door, then the way you do it is This is your X, Y, and Z. You likely just want to modify Z. Okay. I know it's set to quadratic key. You can go to linear key on each of them, and that would be more intuitive. But the thing is, this is in radians, so this is the Z key in radians. You're rotating. This is pi over 2, so you're rotating 180 degrees. So just cut this in half if you want 90 degrees, cut it in half again if you want 45 degrees. And you can mess with the polarity, sidedness, whatever you want to call it, to change the direction. Also keep in mind that the forward and backward values should, first of all, they're typically balanced. So if the one goes forward, eventually that's going to be compensated by a backward motion of an equal summation. But you can see here it's 0. So you just basically just play with these values till you get what you want. But we're doing up and down, we're doing an elevator, so translations times 0. If you want to see the time, let's go to here. These have to be the same, 2.933 and 2.933 here. If you want to change that, you change that there. So let's put 2.933. And let's set it to 256 upwards. Then we're going to go to the other one. We have 0 keys here. We have 2 translation keys. Now, important, remember interpolation, set it to linear key. Again, interpolation, set it to linear key. If not, it's going to crash. So again, 0 to 2.933. Make sure that that's correct. This is not the right one. So I was wrong about that. This is idle. So I understand what they did here. Okay, no. Yeah, that's true. You don't need to mess with this idle because it's in the initial state. Potentially this idle should be set to whatever you put, 0.033 there, 256, because that's where we moved up to. So this is the second portion. It's idle, it's the idle open state. So this is when it's closed, it's at 0, then it moves up, in our case 256. So this should be 256 here. Close that. Open the proper one. 2 keys. Interpolation, set it to linear key. 2.933. That's 0. It starts at 256, so it goes from 256 down to 0. Okay, so let's test that out. So it goes up. Idle, same place, down. We forgot to disable the rotation key, and that's why it was rotating like that. Just save that again. So the whole reason of doing this is, so you might ask, well, why not just use the translate to the garbage? I don't know. I have nothing nice to say about it. the translate to function, the native function, the translate to function in Papyrus. So if we go to, I don't know, this thing, say, translate to blah, X, Y, Z, put in your arguments. That works for stuff that you don't want to mess with as far as collision. So the main thing is collision here. You can ride the elevator. The rotating door will push you out of the way, for example. translate to the collision, because Bethesda doesn't. Again, the thing is, like, I know this isn't like off topic, but these uh, these issues largely in computational geometry and geometric modeling, as far as time series combined with collision hulls, collision meshes. That's not novel. That's not difficult. Uh, Physics engines have been doing that for decades. So the fact that Bethesda is incapable of providing native functions that can do that in a game engine is really pathetic. Again, I'm kind of going off the rails here, but it's just so frustrating to see that. But so here at least we have basic animation. I'll do advanced animation some other time.